Alrighty, so you learned about midpoint and distance formula, and now we're going to talk about simplifying radicals. So, this is the point where you get to learn what are some of the rules of working with the square root or the radical. Alright. So, first things first. There are a bunch of different rules, not really a bunch, but a good chunk. Okay, and the first one is going to talk about what do you do with multiplication? Right? The square root of a product equals the product of the square roots, which means that you are allowed to break up a square root of a number, of a product of two numbers, into those individual products square rooted. So, if you're working with the square root of 9 times 5, which is 45, so it could say 45 under there, it could say 9 times 5, you could reduce that down into the square root of 9 times the square root of 5. The square root of 9 being 3 times the square root of 5, which can't be reduced. You can also go in the forwards direction, and when you are multiplying two square roots, you get the square root of their product. 36, which would be 6. So multiplication, in my opinion, is pretty easy. You can separate it, you can combine it, both are legal. The quotient, I think, is also pretty easy. The square root of number equals the quotient of the square roots of the numerator and the denominator, which means if you are taking the square root of the whole thing, you give the square root to the top, you give the square root to the bottom. So, just like here, if we are taking the square root of 3/4, you do the square root of 3 and the square root of 4, which if you reduce that down and simplify, you get the square root of 3 over 2. Okay, moving right along. Alright, so you know how to simplify now. Now we just need to talk about how you know when you're done simplifying, because that really is the hardest part of simplifying. You know when you're done, first of all, when no radicand have perfect squares other than 1. So radicand is the number underneath. So we don't want that radicand to have any perfect square factors. So for example, if you have the square root of 8, the square root of 8, let's see, you could have 8 equaling to 4 times 2 as their factors. 4 is a perfect square. So this is not simplified all the way. You can change that into the square root of 4 times 2. And we know that we can divide that up into the square root of 4 times the square root of 2. Remembering that the square root of 4 is really 2. So the square root of 8 is 2 times the square root of 2, or 2 square roots of 2. Alright, so square root of 11 has no other factors other than 11 and 1. So this one is totally done simplified right there. That's the simplest form that you can get at. 45, on the other hand, is not in simplest form. I don't believe. Well, let's check it out. What are some of the factors of 45? You've got 1 in 45. You don't have 2 because it's not an even number. You could have 45 divided by 5, which would give you 9, and there's your perfect square factor right there. So, if you are taking the square root of 45, you can change that into the square root of 5 times 9, which is the square root of 5 times the square root of 9, which is 3 square roots of 5. Alright, that's your first thing to look for. No perfect squares underneath. You also cannot have any fractions inside of the radical. So you see this fraction bar that's inside of the square root? Not okay. Alright, so you have to give your square root to both the top and the bottom, just like we did a second ago. So you've got the square root of 7 on top, and the square root of 16 on bottom, which is 4. There you go, simplest form. And since we're talking about fractions, you cannot have radicals in the denominator. This is the hardest part of simplifying right here. I don't think it's very bad. It's not too hard as long as you remember the rules, but it's probably the most difficult part. So we don't want a radical in the denominator. So even though, there we go, we got rid of the fraction bar inside of the square root, but we can't have this square root on the bottom. That needs to go. So you need to think about what a square root is. A square root is the opposite of squared. So the only way to get rid of that square root is to square it. And if you square something, it's multiplying by itself. We can't just square it, because in order to be able to square one thing, you have to be able to do it to the other side, but there is no other side for you to do it. But you can multiply by 1, because you just get the same thing out on the other side. So I am going to multiply by 1. I'm just going to multiply it by something that looks a little bit different than 1, but is still the same. Anything over itself is 1. And if I multiply the square root of 5 times the square root of 5, I'm multiplying it by itself, or squaring it, which gets rid of the root, leaving me with just a 5. And then I have 3, the square root of 3 times the square root of 5, square root of 15. There you go. And the square root of 15 is not divisible by any of your perfect roots. The only factors you have are 1 and 15, and 3 and 5, none of those being perfect roots. So that is our most simplified form. Okay? Alright, let's practice. Okay, let's start with the square root of 125. Now, I don't know about you guys, but I forget a lot of my perfect roots, and I think it's really nice to have a whole list of them when I'm trying to think of what factors I need to look for. So I like to write them 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. I like to give myself a nice list of the first couple, just so I can know what I can divide by. So if I take 125 and divide by each of these numbers, going up, divide by 1, you just get 125 back out. This one's not very useful. Divide by 4, it doesn't give you a perfect. 4 is not a factor of 125, 9 is not a factor, 16 is not a factor, 25 is though. You could do 25 times 5 to give you 125. The square root of 25 is 5, and the square root of 5 hangs around, because we don't know what that is. That doesn't just pop out really nice and easy. Okay. So, there you go. That is my simplest form. There are no factors of the number on the inside here of that 5 that are perfect squares. That would make a difference. The 1 would not make a difference. Alright. How about this one? 2 times the square root of 75. Again, I notice that can be divided by 25. 25 times 3 gives me 75. So I've got this 2 on the outside, 5 square roots of 3. And there is multiplication in between your outer number and any number that you take out, leaving you with 10 square roots of 3 as your final answer. Alright, still chugging along. This square root of 12 cannot be on the bottom. That does not give us simplest form, so I'm going to multiply by 1. But I'm going to multiply it in a way so that it gets rid of that square root. Square root of 12 times the square root of 12 is just going to give you that under number, that 12. And then you have 3 square roots of 12 left there. But the square root of 12 is the same thing as the square root of 3 times 4, 4 being your perfect root. So it's 2 square roots of 3. So instead of writing it like this, I'm going to write it like 3 times 2, which is 6, square roots of 3 over 12. Which, if you take even a further look, 6 over 12, that's the same thing as 1 over 2. So I keep that square root of 3 on top, 1 over 2. There you go. This is my final answer. Nice. Alright. Got another one here. Whoops, let's do that in black instead. You already know that when you have the square root of something on top and something on the square root of a fraction, you can give that square root to the top, give the square root to the bottom. We just discussed over here that the square root of 12 was the same thing as 2 square roots of 3. So I'm going to rewrite that as such, 2 square roots of 3 over 81, which is the square root of 81, which is 9. There you go, right there. Not too bad. Alright, that is the need to know for doing square roots and simplifying those down. This unit is going to move fast. So I'm going to advise you one more time that if you are confused about any of this, ask questions. You might not have time in class, so you might have to take some time out of your own schedule to come in. But you need to ask. Alright. The homework, again, is the same as the midpoint and distance homework. It's just the last bit of that. So you can get going on that. If you need a paper copy, let me know. But we are all done. Have a good one.